In section 4 of chapter 5, we're going to be continuing on what we left off from, which is dealing with addition, subtraction, and multiplication, division of rational expressions, this time utilizing function notation. So first, I want to describe what is function notation. You have all seen function notation in the past. I just want to clarify what it is and why we use it. So I have a bunch of graphs up there. I could reference them based on what color they are or what type of function they are, but I could say, oh, the red function, the absolute value function, that's the function f. That is function notation. Saying f of x is function notation. Then we also have, oh, the blue one, the parabola that's upside down. I could call that the function g. Now I have a function f and a function g. I could also talk about the green equation, the one that you actually don't know what it looks like yet or what the equation looks like. That's the function h of x. And then just for funsies, I'll call the linear function the function delta of x. The first symbol is just a letter. We typically stick with the American, English, Latin-based lettering system, but occasionally we'll go back to Greek, like alpha, delta, pi, omicron, all those things. We might use those Greek letters. It's just the name. Here's why we did that. Because, I feel so dumb for saying this, but believe it or not, this is what the graphs used to look like about 10 years ago. Believe it or not, having colored graphs is a relatively new invention in mathematics. When you have nothing but black and white graphs, it's really difficult to say what graph you're talking about when just looking at the graph. So we had to start naming them. And the way we named them is with function notation. The name of the first function is f, its variable is x. That's where it came from. But with that, we're allowed to do some more advanced mathematical things. I have three functions, f, g, and h. I'm going to do a variety of things to them. I might add them together, I might subtract them, I might multiply them, I might divide them. Instead of rewriting those equations each and every time, I can abbreviate those operations like I do in problem number 1 and just say f of x times g of x. I'm taking these two things and multiplying them together, but instead of rewriting them in their entirety, I could just abbreviate them by their name, f of x times g of x. Function notation also has other useful tidbits that we can use, but I'll talk about those later. Right now, I'm just focusing on you recognizing function notation and then using some basic manipulations with them. So I'm going to take the function f, and I'm going to take the function g, and I'm going to multiply them together. Because I often forget symbols, I'm actually just going to copy and paste these. Copy, paste, copy, paste, and we are multiplying. As long as you're multiplying two rational expressions together, anything that's on top and bottom that are the same can eliminate. Anything that is not the same sticks around. So it's going to be x over x plus 2 times x plus 1 quantity squared. And that is my answer for problem number 1. Problem 2, I'm doing division. So I'm going to take the function h, which I have in green, and the function f, which I have in red, and I'm going to divide the green h by the red f. So that's going to be copy paste the green divided by copy and paste the red, which is the same thing as the green function x plus 1 over x times x plus 2 times the reciprocal of the red function x plus 1 times x plus 2 all over x minus 3. Anything on top and bottom that's the same can eliminate. X plus 2 and x plus 2 eliminate, and that's it, which is why we have the answer of the quantity x plus 1 quantity squared over x times x minus 3. That's my answer here. And then lastly, just because I want to do one more problem involving addition and subtraction, I'm going to have the function g, which is in blue, minus the function f, which is in red. So once again, copy and paste the blue function, and I am going to subtract copy and paste the red function. You can only add and subtract functions together if they have the same denominator, which they don't. So I'm going to have to multiply the first fraction by x plus 2 on top and bottom. And I'll multiply the second fraction by x minus 3 on top and bottom. That would give me, I guess I'll write them over here, x squared plus 2x over x minus 3 times x plus 1 times x plus 2 minus x squared minus 6x plus 9 all over the same denominator. And then lastly, I can combine like terms. The x squares will eliminate because I have x squared minus x squared. So the x squares eliminate. I have a 2x minus a negative 6x, which gives me 8x. And then I'm subtracting a 9 all over x minus 3 times x plus 1 times x plus 2. Top doesn't factor, so we are done.